In this video, I'm gonna solve 3 other probability questions in other Excel files that Utku uploaded to Blackboard. I won't delete that. The first question is, we ask your neighbor to water your sickle plant while you are on vacation. Without water, your plant will die with probability 0.82. With water, it will die with probability 0.06. You are 78% sure that your neighbor will remember to water them. What's the probability that your plant is alive? Firstly, I need to describe events in a probability questions. W, neighbor will water the plants. A, the plant is alive. What's asked? The probability of the plant is alive. So probability A is asked. I need to also mention that constitute a partition. I need to mention about partition. W complement means the opposite of W and A complement means the opposite of A, and their intersections are empty sets. So A and A complement and W and W complement constitute a partition. That's important for conditional probability, also level of total probability. Probability A. Probability A is connected with whether the plants are watered. I mean, the plants might be alive if the neighbor waters them or if neighbor doesn't water them. So probability A is equal from by law of total probability, probability A given W times probability W plus probability A given W complement times probability W complement. That's the probability if that part is the probability if the neighbor gives water to the plants, and that part is the probability of probability that the plant is alive, given that the neighbor doesn't give water to the plants. This summation gives the probability A. So, what's the probability A given W? It writes, with water, it will die with probability 0.06. A complement, probability A complement with water is 0.06. So probability A given W is 1 minus 0.06 times probability water. What is it? 0.78 plus, that's A. Probability A given W complement. It writes, without water, your plant will die with probability 0.82. 0.82 directly. No, it dies. We are looking for it's alive. Sorry. 1 minus 0.82. That's the probability of that the plant is dead, and that's the probability of the plant is alive. Why again? Because A complement, that's the plant is dead, and A constitutes partition. And two events that constitute partition, their unions are sample space, and probability sample space is always 1. Therefore, 1 minus 0.06 for that part and 1 minus 0.82 for that part. I assumed that it might be no, but I also want to mention to you. And if I'm sure that 78% neighbor water the plants, and probability water complement from the constitute from because of constituting a partition is 1 minus 0.78. So that's the probability A, and if we calculate that, we will get 0. That's the probability. Sorry. Yes, it's true. Other part. What's the probability that your neighbor forgot to water given that the plant is alive? Write the question in math. What's asking? Your neighbor forgot to water given that the plant is alive. It means that probability V complement given A. Given that the plant is alive, the neighbor forgot the water, he or it doesn't give the water to plants. Is asked. What can I use there? I will use Bayes theorem because it's hard to calculate that, but it's hard to decide the probability of a given W complement. That I already did here. So, by Bayes probability W given A equals probability A given W complement times probability W complement over probability A. So, what is it? That's here, right? 1 minus 0.82 times 1 minus 0.78 over probability is here 0. And what is it? It's 0.0512. That's the probability of part B. That's it for first question. I have 2 more questions. Okay. What's the second question? A jar contains 5 blue balls and 5 red balls. You roll a fair dice once. Next, you randomly draw, without replacement, as many balls from the jar as the number of points you have rolled with the die. What's the probability that all of the balls drawn are blue? Describe events. B. Drawing a blue ball. R. Drawing a red ball. DI. The dice. It comes from dice. DN, or doesn't matter. N is parameter. Getting result N from rolling the die. That's the events, DN. R and B. Right question in math. what the question asks. What's the probability that all of the balls are drawn blue? Okay. Again, there is a constitute partition from D1, D2, D3, also D6, because their intersections are empty sets. So, probability B is asked. And how can I calculate it? By log of total probability. It's connected what I got from the die, right? And the results of dice are the results of dice constitute partition. Their intersection are empty sets. Probability B given D1. If I get 1 from the die, I will pick 1 ball from the jar, and I am looking for that ball is blue, times probability D1 plus probability blue given D2 times probability D2. It goes like that. I don't want to write all of them. Plus probability B given D3 times probability D3 plus probability B given D4 times probability D4 plus probability B given D5 times probability D5, and finally probability B given D6 times probability D6. I need to compute here. Evet. Firstly, what's the probability that if I will drop only 1 ball from how many balls? 5 blue balls and 5 red balls. That's the combination. 5 chooses 1 over 10 chooses 1. I will choose 1 blue ball from 5 and I will choose 1 ball from 10. That's possible outcomes, that's favorable outcomes. Times 1 over 6 is the probability to get 1 from the die. From the dice, sorry. Dice is plural. Plus, when I get 2, 5 chooses 2 over 10 chooses 2 times 1 over 6 plus 5 chooses 3 over 10 chooses 3 plus 1 over 6 times 1 over 6 plus 5 chooses 4 over 10 chooses 4 times 1 over 6 plus 5 chooses 5 over 10 chooses 5 plus 1 over 6 plus I am continuing to that 5 chooses 6 over 10 chooses 6. That's 0. Also plus 1 over 6. That's 0 because I can't choose 6 balls from 5. So that's 0. That's 0. If we calculate all of them, we will get, that's equality, we will get 0.9. Actually, when we do operation closely, that's the probability when we calculate here. Other part, what's the probability that the number of balls, the number of points shown by the die are equals 4, given that all of the balls thrown are blue. Okay, write the question in math. It says for probability D4 given that probability B. Given that all of the balls thrown are blue, what's the probability that the die is 4? And it's equal to bias. Probability B given D4 times probability D4 over probability B. Probability B given D4 means I already did there 10 chooses 4. I can write that. 10 chooses 4. 5 chooses 4 over 10 chooses 4. Equals 5 chooses 4 over 10 chooses 4 times 1 over 6, that's the probability D4, over probability B that I already calculated here. 0.139. And that gives 0.029. Closely. That's the probability of D4 given B. Other question. The video is long, but questions are also long. I can't do much thing. Also for my handwritten, elinizin çok iyi değil yani. Ama elimden gelince anlatmaya çabalıyorum. Umarım anlaşılır olur. Yani okuyamadığınız yerlerde videoyu durdurup da biraz tahtaya da bakabilirsiniz. YouTube'u yüklerken kalite düşerse bilmiyorum ama en azından sesi tekrarlıyorum. Bunun bir faydası olur diye düşünüyorum. Other question. A new test is designed to find a particular gene that makes people immune to a infectious disease. The test finds the gene with probability 0.85 and the probability of a false positive is 0.28. The person does not, if the person does not have the gene. It means false positive. Before the test is done, the researchers believe that the probability of presence of that particular gene in population is 0.46. Use bias rule reveals the value of the probability of the gene being present in a particular person, given that the test gives a positive signal. Describe the events again. I will T that test is positive and G the gene is present. That are two events. Describing the events always makes the question easier, much easier. Okay. Write the question in math. What's asked? The product of the gene being given that test gives positive signal. Probability of gene being given that test gives positive, right? Okay. Given that test gives a positive signal, probability of gene being present. Yes. That's test. What I can do? We will use bias theorem again because that's hard to calculate, that's hard to know, but knowing controversy of it is much easier. Let me show. Probability G given T equals probability T given G times probability G over probability T. That's easier. That means the test finds the Gini by giving positive signal, and that's already given, and that's we need to calculate probability T. Firstly, I will calculate it here. It might be long sometimes. Probability T is the Gini can be present or cannot be present. So to give a positive signal is connected to events that constitute partition. That is G and G complement. Their intersection are represent. Probability T equals, I will delete here. By law of total probability, probability T given G times probability G plus probability T given G complement times probability G complement. That's G. Okay, what's it? The test finds the Gini with probability 0.85. The finding means the Gini is present and the test gives positive signal. 0.85 times. The Gini in population is 0.46. That's the probability of P Gini plus if, no, not if, that's not complement. Probability T given G complement. What's G complement? The Gini is not present, but the test gives positive signal. That means false positive, and its probability is 0.28 times G and G complements, as I've already shown here, constitute partition. So probability G complement is 1 minus 0.46. 0.46. When I compute that, I will do it right now, or I will check it. Oh, I have to. 0.46 times 0.86 times 0.46. Here, 0.300 plus 7. And that's equal to 0.392, 0.1512. That's equal to 0.5432. That's the probability T. But I'm asked for probability G given T. So I'm doing here, what's probability T given G? 0.85 times 0.46 over 0.5432. Sure, that's equal to, what is it? I'm checking. point closely also. Closely. That's all for that video. I solved 3 questions. Thanks for listening and watching. See you.